Let me break down some of the terminology you just saw in that video because it comes with a little bit of technological knowledge and know-how. Some of the things that you should know we'll be talking about in this class. One of the things is the X.25 protocol that you heard. We could just simply call that dial-up. So did you know in the United States 8% of internet users still access the internet via dial-up? That's amazing at this point. The TCP/IP protocol is the internet that we use inside of Malloy or we use anywhere. That's a very fast internet that accesses through a modem. So when you hear that, you're thinking of a modem. It's that blinky thing in your house. But what you don't know about your modem, and I want you to take a look at it at some point, is when you see your modem and you see the little blinking light, those things act sort of like the way that those race cars work in a Hot Wheels set. It goes down and it speeds up as it wraps around. When every time it blinks at your house, it's actually your internet, the neighbor's internet or everyone's internet around you traveling through your modem, making it faster. It's making the internet move quicker. So the more people that have modems, the faster the internet goes. The more technologically we go, the faster it is. Now, one of the things and fun facts about the United States is that we do not have the fastest internet. That goes to many other countries. In fact, we're very slow. But that has to go along with the lines that we kind of set the wires up. Because the United States came up with the telegram and the telegraph wire, we ran the internet across those wires to begin with. Those are really slow connections. So countries that are more developing and starting now are starting with fiber to begin with, which is super fast. That's light speed. So they're already starting with the fastest type of internet. We have to build up to the internet. So we're still getting there. Well, in the 1950s, we started DARPA, and as you saw from the history of the internet, it went through several processes in order to get to our modern internet. But some things you should know about the next few decades are pretty important. One is how did we start interacting with machines themselves? So you saw at the beginning, there was a frustrating process known as batch processing. You had to put a card and put the program on it, and put the program into the machine, and the machine was able then to think a certain way. You then had to work with the machine thinking on that way. So all of your batch processing was required to go through that type of machine thinking. On the idea of moving past the transistors to actual storage devices using silicon, the ability to store media on something other than transistors and other than on tubes, we were able to have the machines carry more data. That becomes the Moore's Law, made by a guy named Gordon Moore. And what Gordon Moore said is that for every 2 years that goes by, transistors will get twice as fast and the cost will come down twice as much. And what he means is that the machine itself will get smaller by half and then cost half of that. So if you look at it, you can even see that like a small SD card, even the one that I'm recording on at this moment, is a 32 gigabyte card, and that 32 gigabyte card cost me about $8. 2 years ago it would have been 30. 2 years before that, it potentially would have been hundreds. So at some point in our history, we had to interact with a machine in a different way. And for the first time in 1965 and around then, we started talking about the graphical user interface, the GUI. Some of you may already know this term, GUI, GUI. It's how you interact with a machine. You see a machine through its screen, through its interface, through its monitor. That wasn't always the way. In fact, that's only 50% of what we have as far as computing is concerned. You could use a peripheral, whether it's a mouse or a clicker or even a pen, to interact with some sort of device that makes the machine work. So start thinking about things this way. You have an easy access point to making a machine work from the inside out by touching graphics. You don't actually touch anything as far as the machine is concerned. You touch a graphic, and that graphic interacts with the machine. So you have to start thinking differently and understanding that you are a human and the machine has an interface before you reach the machine itself. So now you've been separated by one level. It's made it easier, but it's also made it more accessible. Now people everywhere can use computers. By moving past the graphical user interface, the transistor itself became something more digitized, more chip-based, microchips. And inside of those microchips, we had the ability to interact faster with the machines. And so a microchip is a small object that holds tons of data at once because what it does is it electronically charges some of the gold and some of the electrons on there to keep data in the form of binary, language, ones and zeros, so tightly packed that we can store tons of information simultaneously, which can be accessed. Now, of course, then we have to go to the next piece of the machine, the processor. Because the processor is the way that the machine can then interact fast. Now, the faster it goes, what happens? Similar to rubbing your hands together, the faster it goes, the more heat appears from it. So now you have to start thinking about how to make the processors cooler, which means they were bigger. Now at a certain point, they were able to be cooled on their own, new technologies came out. And in the late 1970s, a couple of dudes in their garage by the names of Steve, Bill, and a couple of others got together and started thinking about how to make a machine more personal. How do you make it a personal computing device? And so what you saw was the birth of software, like Microsoft, and you saw the birth of hardware, like the Apple. And you could see these births by understanding that these are the beginnings of how technology becomes usable to the masses. In 1984, Steve Jobs launches the Apple Macintosh. So first there was the Apple, and then the Macintosh. And the Macintosh's goal at the time was to be the anti-PC, the anti-IBM. Move away from Microsoft, because Microsoft was becoming this mega company, so big that it was undefeatable, that everyone was using it. And so Steve Jobs wanted to see this intervention of trying to make it so it wasn't just him, it wasn't just Microsoft running everything, that there would be an OS that could work with that, work against that. And so the Macintosh comes out with a new graphical user interface and more accessible buying options. At the time, the commercial, which you'll see in a few seconds, that commercial tells us something that's very important to today's culture. It tells us that it won't allow an Orwellian future to appear, because that Orwellian future would be a Microsoft-based way. So let's take a quick break and watch this commercial.